Recall that the scope of any variable is the workspace in which it is valid. The workspace that is created in the command window is called the base workspace. Scripts also create variables in the base workspace. So that means that variables you create in the command window can be used in scripts and vice versa. However, that's a really bad idea. That's very poor programming style. Also recall that variables that you find in functions are local to the function. Functions use their own workspaces. Every function has its own little workspace, and so variables that you create within functions do not interact in any way with variables in the command window or from a script. Persistent variables, first of all, are only used within functions. So I'm going to contrast persistent variables with what I'll call quote-unquote normal variables. So when you have a normal variable in a function, the memory is allocated when the function gets called or when it's invoked, and then that memory is released when the function stops executing. With persistent variables, on the other hand, the memory stays allocated and the value remains in that location even after the function stops executing. Now, in order to have a persistent variable, you have to declare the variable first as persistent. What declaring does is it allocates space in memory for the variable, but it doesn't have any value in it. So normally an if statement is used to check to see if it's empty, meaning you've just declared it for the first time, and if so, initialize it to a value. A counter is a good example, counting how many times the function is called. So you would check to see if it's empty, and since you're going to have a counter, if it is empty, then you would initialize it to 0. And if you want to reset persistent variables, the command clear functions will accomplish that. So here's an example of a program that shows a quote-unquote normal variable versus a persistent variable. So what I have is a script called persist, short for persistent example, and it's going to demonstrate persistent variables. So what it's going to do is it's going to call one function that has a quote-unquote normal variable called count twice, and then it's going to call another function which has a persistent variable twice. So we'll see what happens. We'll see what the difference is. So we start with the script, and it prints, this is what happens with a quote-unquote normal variable, and then it calls func1. So that sends control to func1. Notice in the function header it's pretty minimal. We're not passing any arguments to the function, nor is it returning anything. So we just have function and then the name of the function. So the first thing we do in this function is say count gets the value of 0. So what that's actually going to do is create some location in memory. We're going to refer to it as count, and we put a 0 in it. Then it increments count. Count gets the value of count plus 1. So now count has the value 1, and we're going to print the value of count is 1. Now that's the end of the function, so that sends control back to the script, and when control goes back to the script, this location goes away, so that only exists while the function is executing. So back in the script, what we do is call func1 again. So once again, that sends control to this function. Once again, we start by saying count gets a value of 0, so that's going to allocate some location in memory that we're going to call count, and it's going to put a 0 in it. And then we're going to increment count. Count gets the value of count plus 1, so count gets the value 1, and we're going to print the value of count is 1, same as before. And that's the end of the function, so control goes back to the script, and when that happens, our variable count goes away. Okay, so then we're back in the script, and we're going to print, this is what happens with a persistent variable. And now we call the second function, func2. So again, the function header is minimal. We don't pass any arguments to it, nor does it have any output arguments. And the first thing we do in the body is to say persistent count. So what that does is that allocates some location in memory, and we're going to refer to it as count. But that's all it does. It just allocates the location in memory. Then we say if is empty count. Well, it is. It's there, but it's empty. So we're going to execute the action and initialize count to have the value 0. Then we increment count to get the value of 1. So count now gets the value of 1. And we print the value of count is, and the value of count, which is 1. Now that's the end of the function. So control goes back to the script. When control goes back to the script, that stays there. This is a persistent variable, so this location stays allocated. So we're back in the script. We call the function func2 again. That sends control back to the function. First thing we have is persistent count. Well, basically we don't have to do anything here because we already have this persistent variable count. It's still there. So then we have an if statement. If is empty count. Well, it's not empty. It's got a 1 in it. So we skip the action. We go down to the next statement, which says count gets the value of count plus 1. So count now is going to get the value of 2. And we're going to print the value of count is and the value of count, which is 2. And then that's the end of the function. So control goes back to the script. And again, this location stays here. It's kind of hard to see this, but we have a 2. I'll write it over here on the side. We have a 2 in that location. So we're back in the script. That's the end of the script. So that would take us back to the command window, and we still have this location, and count is still 2. So if I called the function func2 from the command window now, that would send control to the function, and we would end up incrementing count to have the value of 3. And it would keep incrementing every time we call the function from anywhere because it is persistent. That location is going to stay there. When you're working with programs, it's important to understand different kinds of errors that you can have. There are syntax errors, which are mistakes in the language. For example, you start a quote and you forget the end quote at the end of a string or something like that. MATLAB's pretty good at flagging that kind of error for you. A runtime or execution time error is something that you can find when you're executing the script or the function, but you can't know ahead of time that it's going to be an error. For example, referring to an element of a vector that doesn't exist. Now, you could extend a vector, that's okay, but if you tried to refer to an element of a vector to print it, for example, and it doesn't exist, then you would get a runtime error. There are also logical errors. These are the worst. Logical errors are errors that are not mistakes in MATLAB, but they're a mistake in your reasoning. So for example, if you have an expression like 0 less than x less than 10, you put that, let's say, in an if statement. If 0 is less than x less than 10, and you think that that's going to be true only if x is in the range from 0 to 10, well, you're wrong. That expression is always going to be true. So that would be what's called a logical error, and you may not get the result that you would expect, but you're not going to get any kind of an error message either. So there are several ways that you can find bugs or errors in programs. One is tracing. That means going through statement by statement and seeing what happens. So you can use the echo statement, which is a toggle. You turn it on and then it will show you all of the statements as they're being executed, and then you can turn it off again. So for example, you could see how many times the action in a for loop is executed, or you can see which action is executed in an if-else statement. You can also use MATLAB's editor debugger, and in that what you do is you set breakpoints. So the statements that you use start with db, that's short for debug. So for example, db stop allows you to set a breakpoint. So you can say stop at this particular line, and then you can examine the values of variables and expressions to see what they are at that point. And then db cont will continue the execution, and db quit gets you out of this debug mode. Here's a notion of what's called function stubs. Function stubs can be used to prevent bugs or errors in the first place, and if you do make mistakes, it makes them easier to find. So the idea is this. You put the quote-unquote main program, you write the script. So in the script you say, okay, I know I'm going to have a function that's going to get this input, then I'm going to have a function that calculates this one value, and then I'm going to have another function that calculates these other two values, and I'm going to have a function that plots something. So you figure out basically what you need to have in the script. So in the script you put in all of your function calls. And then you create M files for all of these functions, but you don't actually write all of the function definitions yet. What you do is you write sort of a dummy M file for each function. So the function is going to consist of the function header, and you know exactly what the function header is going to look like. Once you have written the script, you know the names of the functions, you know how many values you're passing to the functions, and you know how many values the functions are returning, if any. So you can write the correct function header for every function. But then instead of filling in the actual body of the function, you fill in some kind of dummy body. It sort of does what the function is going to eventually do, but doesn't really. So for example, if your function is going to prompt the user an error check for the radius of a circle, you could just say radius gets a value 3. So you're not really prompting, you're not really error checking, you're not doing anything, but you allow the function to return a value. Just to see when you execute the script that the script is actually correctly calling all of the functions. So then what you do is once you have the script and you have all of these dummy functions in place, is you go back and you fill in the actual function bodies one at a time. So when you do that and you find a mistake, you know where it is. It's the function you're working on right now. That's a whole lot easier than writing the script and all of the functions and then executing all of it once, and then you have no idea where the actual error is once you get errors. So it's a lot easier to go about things in a methodical way. It does help you prevent bugs in the first place, and if you do make mistakes, it's easier to find them if you follow this procedure. Code cells and publishing are really neat things in MATLAB. You can take a script and break it down into sections that are called code cells, and then you could run one code cell at a time, so you don't have to execute the entire script at once. So the way you create code cells is you start with comments that start with 2% symbols rather than just a single one. So anytime you start with 2% symbols for a comment, that creates a new code. Once you have code cells, you can publish the code in the code cells in HTML format with the plots and formatted equations embedded within it. And you can also do this from the Publish tab in the editor.